Welcome to Properties of Real Numbers in Algebra 2. Here I have a diagram and I have real numbers. All real numbers are numbers that we can see on a number line. They're divided into two sections. You have we use I to stand for irrational numbers. And these are your radical 2, radical 7, 22 over 7, or pi. Irrational numbers have no patterns. When looking at the square root of a number, if it is not a perfect square, then if you were to solve it, then you would have an irrational number. Okay, notice radical 2 and radical 7, they are not perfect squares, meaning you can't take a number out of them, and therefore you're going to end up with a decimal that never ends and has no pattern. That is why it is irrational. On the other side, we have our rational numbers, and we're going to use the letter Q to represent rational numbers. These are numbers that make sense. They're the ones that have the patterns. They don't have never-ending decimals. They actually do stop. They make sense. They're rational. Think of a person that's irrational and a person that's rational. Okay? Within a rational number, we can divide them into a couple different sections. If I work from the innermost and put a little circle in there, this is what we call our natural numbers. We're going to use n to represent natural numbers. And these are 1, 2, 3, 4, and so on. And they start with 1. Then we have what we call our whole numbers. Use a W for whole. And the difference between the natural and the whole numbers is a whole number starts with 0. 1, 2, 3, 4, and so on. No decimals. Okay? No decimals. And then we have what we call our integers. And because we use the I for irrational, we're going to use a Z to represent integers. Integers are our negatives, include 0, and our positives. And then everything else is a rational number, or a Q. And this is where your fractions would fall into, or decimals. Okay, that's where everything else goes. That it has a pattern and it ends. What they're going to ask you to do is calculate or classify numbers based on what they are. So if we take a look at example number 1, radical 6. Okay, now everything in this blue box is a real number. So, radical 6. Well, I know it's going to be a real number. I can see it. So I'm going to put an R down because it's a real number. Is it under the rational or irrational? Well, I take a look at it and I say radical 6. 6 is not a perfect square. If I were to solve radical 6 on the calculator, I would not get a whole number, so therefore it is irrational. Remember, all square roots that are not perfect squares are irrational. So my answers are I. Let's look at another one. 3/8. Now, it's definitely a real number. I'm working with all real numbers, so you're going to always have an R. Later on, we'll work with imaginary numbers. Those are numbers you can't see. Okay? I have to decide if it goes under the I's or the Q's. 3/8 is, I'm not looking at the square root. Okay? This is a special fraction because it's pi, which we also know is never ending. 3/8, when I divide 3/8 on a calculator, I hate using a calculator because they always round up. If I were to say 3 divided by 8, okay, notice I get 0.375, so that falls under the Q, or the rational section. So I can put 3/8 here, and that's as far as I can go. Let's look at number 3, -9. Now, I like to work, well, we definitely know it's a real number. It's in the blue section. We're dealing with all real numbers. And I like to work inside out. And I ask myself, is it a natural number? 1, 2, 3, 4, 5? No. So I go to the next section. Is it a whole number? 0, 1, 2, 3, 4, 5, and so on. No. So I go to my integers. Integers are my positive and negative numbers. It is an integer. Okay. And my next step up is Q, or rational. So it's also a Q. Okay. We're going to be doing some more of those examples later on.